In this video, we will be discussing the properties of parallelograms, and we will use those properties to prove that triangles are congruent. So, first of all, as soon as we find out that a quadrilateral is a parallelogram, we have these 5 things to work with. The first one is the definition. The opposite sides of a parallelogram are parallel. So that's the definition. So as soon as I see opposite sides parallel, that's the definition of a parallelogram. The other 4 are properties. Opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other, and consecutive angles like these are supplementary. Okay, so just keep this in mind. But don't forget, only the first one is the definition of a parallelogram. So, okay, PARL is a parallelogram. Mark this diagram based only on the definition. So the definition of a parallelogram is that opposite sides are parallel. And the way you mark parallel is with arrows. Hold on. Okay, just put little arrows on it like this. Okay, so those are parallel. Also these are parallel. And so I'll put 2 marks on these to show that these are parallel. All right, I'll double mark it. Okay, I'm not happy with the way I did the first one. All right, there we go. Opposite sides are parallel. Now, list the 4 properties of a parallelogram and label the diagram based on each property. So, opposite sides are congruent. I'm debating if I should write the word out, congruent. Opposite sides are congruent. So, for example, this is congruent to this, and this is congruent to this. Property number 2, opposite angles are congruent. Okay, so this angle will be congruent to this angle, and this angle will be congruent to this angle. Property 3, consecutive angles are supplementary. Which obviously means that they add up to 180. So if this angle is 80 degrees, then this must be 100 degrees. And finally, the diagonals bisect each other. So that means they cut each other in half. So PE would be congruent to ER, and LE would be congruent to EA. So, given that PARL is a parallelogram, in the space below, list all the pairs of angles that must be congruent. Okay, so opposite angles are congruent. So that means that angle 5 must be congruent to angle 2. Okay, because of these lines being parallel right here, okay, because this line is parallel to this line, and then here I've got my transversal. Then I'm looking at alternate interior angles for angle 1 and angle 4. So that means that angle 1 must be congruent to angle 4. Okay, let me erase that for a second. But of course, the other pair of lines are also parallel. So because AR is parallel to PL, if I draw the transversal, then you will quickly see that angle 6 and angle 3 are alternate interior angles. So angle 6 must be congruent to angle 3. All right, time for a proof. All right, the first one, they were kind and gave us most of the stuff, or like half the stuff. So we're given that it's a parallelogram. All right, so fine. So we can go ahead and say, because it's a parallelogram, we can use the properties of a parallelogram. One of the properties says that opposite angles are congruent. So angle P should be congruent to angle R, and because opposite sides of a parallelogram did I say sides? My goodness. These are angles. Opposite angles of a parallelogram are congruent. All right? That's what we put for the reason. Okay, now we have additional information. AL bisects angle PAR. Okay, so look, here is angle PAR. PAR is up top. Okay, in fact, I could say it this way. Here is angle PAR right here. Now, along comes segment AL and bisects that. And we know that bisecting means that it splits it right down the middle. So that breaks this angle into two congruent parts. So I will immediately say that angle PAL, all right, so it's this first half, angle PAL is congruent to angle RAL, the other half. Okay, and that's going to be the definition of angle bisector. Notice how these match up. In the previous statement it said bisects, and here we have definition of angle bisector. Now, I notice that the next reason says reflexive property, so I immediately start looking for a shared side, and there it is right here. This is a shared side. So I'm going to go ahead and say that AL is congruent to AL. All right, because that's how we handle the reflexive property. AL is congruent to AL. Okay, now looking at the markings, that is enough information to prove that the triangles are congruent. So we can say that triangle PAL, all right, that's the left triangle, is congruent to triangle RAL. The order matters, so be careful to put corresponding angles in the same position. Okay, and that's going to be angle, angle, side. I have two angles and the side that is not in the middle. So we call that angle, angle, side. Okay, but that's not all we were being asked to prove. We were asked to prove that specific parts, all right, these segments, are congruent. So whenever you have already proven that the triangles are congruent, and then you have to go on to show that specific corresponding parts are congruent, I bet you can guess what the reason's going to be. Because we know that corresponding parts of congruent triangles are congruent. So we write CPCTC to abbreviate that. Corresponding parts of congruent triangles are congruent. Make sure you know what those letters stand for. All right, so that is it for proof number 8. Okay, let's keep going. You might find it helpful to draw a picture first. For each part of this question, you must show work. All right, so we're given that these triangles are congruent. So let's decide which segments are going to be congruent. So for example, I see that AB is first, and then in the next triangle we have DE. So I know that AB is going to be congruent to DE. All right, or you know what, I'll just say that length AB is equal to length DE. Okay, let's keep going. Similarly, see how B and C are last, and then E and F are last. So that tells me that length BC is equal to length EF. All right, but there's one more of these that I can make. If I look at the first and the last, so I see A and C, first and last, and then D and F. Okay, maybe I'll just do a different color. Okay, so AC is equal to DF. All right, so I know that those parts are all equal. Those lengths are all equal. So let's look for a match. So I have AB and DE. All right, I see AB, but I don't see DE. All right, how about BC and EF? I see BC, aha, here's BC, and here is EF. So that is a match. Okay, while I'm at it, I'll switch colors, because here we also have AC is equal to DF. And here's AC, and here is DF. So that is another match. Okay, so if I want to find the value of X, I'm going to use the fact that BC is equal to EF. All right, in other words, 4x plus 12 is equal to 72. Subtracting 12 from both sides, that's going to give us 4x is equal to 60. And then dividing by 4 on both sides, that's going to give us that x is equal to 15. All right, now I want to find the value of y. So I'm going to use the fact that df is equal to AC. So in other words, 6y minus 12 is equal to 66. So if I add 12 to both sides, that's going to give me 6y is equal to 78. If we divide both sides by 6, we find that y is equal to 13. Okay. Now, finding the value of z. Oh, okay. I guess we have to mess around with these angle measures down here. Maybe I should make a list of congruent angles the same way that I did for the segments. So angle A is congruent to angle D. All right, so we know that angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Okay, so keep that in mind. So let's see. Now let's look for a match. A and D, those are not on the list. How about B and E? I see B, but there's no E. How about C and F? Well, there you go. Angle C is congruent to angle F. So that's what I'm going to use to solve this one. So that tells me that 8z minus 9 is going to equal 71. So of course, if I add 9 on both sides, that's going to give me 8z is equal to 80. And dividing both sides by 8, we see that z is equal to 10. Okay, so next we're asked to find the measure of angle E. We're not given an expression for that, but we know that angle E is congruent to angle B, which is on the list. So if I want to find the measure of angle E, that should equal the measure of angle B. Okay, so the measure of angle E should equal 7z minus 4. But we now know that z is 10. So that means the measure of angle E should equal 7 times 10 minus 4. So that tells me that the measure of angle E is going to be 7d minus 4. So that tells us that the measure of angle E is going to be 66. All right, looking at number 10. We're given expressions for angle P and angle A. So angle P and angle A are consecutive angles in this parallelogram. Consecutive angles like this are supplementary. If they were across from each other, they would be congruent. But they're not. They're right next to each other, so they are supplementary. So that tells me that the measure of angle P plus the measure of angle A has to equal 180. So that means that 4x plus 35 plus 6x minus 15 is equal to 180. Combining like terms, that's going to be 10x, right? I'm doing this. These are like terms. And of course, these are like terms, so combining like terms. I'm going to have 10x and then plus 20 is equal to 180. Subtracting 20 from both sides gives us 10x is equal to 160. So then if we divide both sides by 10, that tells us that x is equal to 16. Okay, and I guess that was all we were supposed to find, is the value of x. All right, last one. So we have angle P and angle R. So here's angle P and here's angle R. In a parallelogram, opposite angles are congruent. So that tells us that the measure of angle P should equal the measure of angle R. Okay, so that means that these expressions should be equal to each other. So I'm going to write 6x minus 15 is equal to 4x plus 35. I know I kind of swapped these. This one goes with R, this one goes with P. I try to put the bigger x value on the left to keep the numbers positive. Anyway, so I can't just combine like terms because these are on opposite sides of the equation. So I need to subtract 4x from both sides to get them on the same side. So that's going to give me 2x minus 15 is equal to 35. And then I would need to add 15 to both sides. So that's going to give me 2x is equal to 50. And then dividing both sides by 2. That tells me that x is equal to 25. All right, so that was it for number 11. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.